Section 4.2, logarithmic functions. A logarithm is the inverse of an exponent. What that means is log base a of x equals y is the same thing as saying a to the y equals x. In both cases, a is called the base. Here it's the base number with the exponent, and here it's the base of the logarithm. And here we would call y the exponent, and that's what it is here as well, it's the exponent. So really what log is saying is a to what power equals x. So asking the question, what power? So here's some examples. Log base 10 of 100,000. That means 10 to what power is going to equal 100,000. So that would be to the fifth, because 10 to the fifth is 100,000. Log base 2 of 8, that means 2 to what power equals 8. So we know that that should be 3. Log base 2 of 1 over 8, that's 2 to what power equals 1 over 8. So we know 2 to the third is 8, so to get 1 over 8, that's going to have to be a negative. So that's negative 3. The negative flips the fraction, 3 makes the 2 become an 8. Log base 10 of 1,000, that's 10 to what power is 1,000? So that would be 3. Log base 2 of 32, 2 to what power is 32? 2 to the third is 8, so 2 to the fourth would be 16, so 2 to the fifth is 32. Log base 10 of 0.1, 10 to what power is 0.1? That's 1 over 10. So to flip the fraction, that would have to be negative, and it stays at 10, so negative 1. And log base 16 of 4. 16 to what power equals 4? Well, the square root of 16 is 4. As a power, that would be 1/2. Square root is 1/2 power. So the graph of a logarithmic function, since logs are the inverse of exponents, we know an exponential function looks like this. And we know that since it's an inverse function, that it will be a reflection over the line y equals x. So if you reflect it over that, it will look like this. So the logarithmic function looks like this. The slope and everything of it depends on the base of the log, just like exponential function depends on the base as well. So here's log. And this is the exponential function. So if we're going to sketch the graph of log base 2, we can make a table and think about this a little bit. So for this, we got to think about exponents and powers of 2 a little bit backwards. So start thinking of the powers of 2. We know we could obviously do 2, 4, and 8. But you can also, 2 to the 0 power would be 1. And that's enough. That's 4 points. So if we just said 2 to what power equals 1, we said that would be 0. 2 to what power equals 2, that would be 1. We know 2 squared is 4, so 2 to what power, that would be 2. And then 2 to what power would equal 8, that would be 3. So in this case, for logs, our output is the exponent we have to think about, and then our input has to be the actual powers of 2. So 1, 0 is a point, 2, 1 is a point, 4, 2, and 8, 3. So it's going to go through all of those points. And then from before we saw that's going to have a vertical asymptote. So our domain for logarithmic functions is only values of x greater than 0. There's a vertical asymptote at x equals 0. So we can go back, we can write that about the domain. Be 0 to infinity, not including 0. The range could be anything. Goes down to infinity, negative infinity, and keeps going up to positive infinity. So then all the transformation stuff still applies. So the basic graph of log is going to look like this. So if a negative out in front is going to reflect it over the x-axis. So rather than looking like that, it's going to be reflected over the x-axis, and it will look like that. A negative in front of the x is going to reflect it over the y-axis. So again, instead of looking like this, it will be reflected over the y-axis, more like that. So there's some basic properties of logs as well. Log base a of 1 equals 0. So a to what power would equal 1? Well, anything to the 0 power equals 1, so that's where that property comes from. Log base a of a, that means a to what power equals a? Well, that would be a to the first. We could say this is because a to the 0 equals 1. This is because a to the first equals a. Log base a of a to the x is x. That's because a to what power would equal a to the x? Well, a to the x equals a to the x. And this one is actually just the flip of what we wrote over here. Basically, the bases always cancel out. So a as a base with log and the exponent will cancel out. So that'll just simplify to x. So if we evaluate these, 5 to what power equals 1, that'd be 0 power. 5 to what power equals 5, that'd be the first power. 5 to what power equals 5 to the 8? That'd be 8th power. And we know that the bases cancel out, so this is just 12. And then two special cases for logs. The common log is base 10. That's because our number system is base 10, so we don't need to write base 10. If you just write the word log, that automatically means base 10. And then the natural logarithm is base e, so natural log ln is base e automatically. And those are the only two that you'll see on your calculator. You don't get buttons for all of them because that would be too many. So there is a log button and a natural log button, but that's usually it. And then with natural log, just like any log, all those properties apply. So you could say natural log of e, that's e to what power equals e, so that's 1, things like that. Natural log of e squared, natural log cancels out e, so it'll just be 2. E to the natural log of any number, let's say 8, e and natural log cancel out, so just be 8, and so on. If you were given something like find the natural log of a number like 5, you just have to type that into your calculator, natural log of 5, use the ln button, and that would become, or that would come out to about 1.609. That's about it.